If you know a bit about science, you've probably heard of one of its most fascinating phenomena: quantum entanglement. It's the kind of thing that makes even scientists pause and ask, how can this be possible? Let's break it down. Imagine two separate microscopic particles, each with its own measurable properties, like energy and charge. Now, suppose we bring them together and make them interact. In that moment, a new quantum system emerges, one that can no longer be described simply by the individual properties of each particle. Their states become linked in such a way that measuring one instantly influences the other, regardless of how distant they may become. Something remarkable has just happened. The two particles have become entangled. From this point on, you can't really talk about one without mentioning the other. It's as if they're performing an invisible dance together, perfectly in sync, no matter how far apart they drift. Their realities are now intertwined, connected by a quantum wave of probabilities that ripples through a vast ocean of possibilities. And here's the truly astonishing part. You can separate them by an inch or by light years, and they'll still behave as one. Any change in one particle instantly dictates the state of the other. Their connection is immediate, defying the limits of the speed of light. Space and time, the great pillars of our physical world, suddenly don't seem to matter. Their connection exists beyond those limits, like two notes of the same chord resonating in the spaceless music of harmony. Even across the vastness of the cosmos, they keep dancing together, forever partners in this strange quantum waltz. If you like analogies, and who doesn't, imagine pixels on a computer screen. They may appear very distant, yet their unity exists not on the surface of the screen, but deep inside the microscopic processor. The screen only gives the impression of separation, which does not exist beneath. The same is true for entangled particles. The distance between them is simply absent. Even stranger, microscopic particles can be entangled through time. They do not just dance together across the three dimensions of space. They can stay connected across different moments, linking the past, present, and future. In quantum mechanics, space and time are treated almost as equals, so this idea fits surprisingly well. Scientists call it temporal entanglement. It means that a single particle measured right now can show a direct connection to another particle that appears billions of years later, or one that existed long ago. Two particles can influence each other, even if they never existed at the same moment. Quantum reality, it seems, refuses to be limited by time. It suggests something almost unbelievable. The future and the past are not as strictly separated as we experience them. Certain quantum interpretations even propose that measurements made now can influence what happened earlier in a particle's history. You might wonder what any of this has to do with us, beyond the fact that we are all made of the same particles, atoms, that can become entangled. A physicist may argue that these quantum effects are negligible for humans, since we are vastly larger than the tiny particles that obey quantum rules. Negligible, however, does not mean non-existent. There is also something important we still do not fully understand: how the brain actually works. Navigating a complex world, processing vast amounts of information, and maintaining a continuous sense of consciousness may rely on principles that look very different from the way classical computers operate. Some researchers propose that the brain could be using forms of quantum computation, If that is true, then our minds might be woven into quantum reality much more deeply than most scientists currently assume. Now, if we bring this down to the human level, you'll see the meaning in it. Picture two people living their separate lives, each bound by habits, memories, and attachments. Then, one day, they meet. And suddenly, a new state of being appears, something that cannot be explained by their individual pasts. They may drift apart, but something remains, an invisible thread that resonates between them. Even across distance, they feel each other's presence, for they are, in a very real sense, entangled in love. And love, like quantum connection, transcends in space-time. What if the entanglement of our minds extends through time? What if we are connected not only to the present moment, but also to future and past versions of ourselves? Our choices right now might send ripples through the timeline, shaping events that have not happened yet, and even influencing how earlier moments must have unfolded. It would mean that our lives are not a simple, one-way path. They might be part of a larger, interconnected story where every moment communicates with every other. So what does all of this really mean for us? Could we, in some way, sense something from the distant past or far future? Could events long gone still be shaped by what we do now? If our brains use principles similar to quantum computation, then quantum effects might connect us across space as well as time. Even if loved ones from our past are no longer alive in the present, we might still be entangled with them because they continue to exist in the time where they lived. The past may not be gone. It may simply be another dimension of now. You have probably experienced moments when you can vividly recall a conversation or a scene with someone who is no longer here. Every detail returns: a gesture, a smile, even the soft movement of the air around you. It feels like you are right back in that moment. Perhaps it is because what you call the past is still the present for them. They continue to live and experience, just not in the slice of time we currently occupy. There's something fascinating you might not know, though scientists do. If a pair of particles is quantum entangled and one is separated from the other by vast distances or even time, something remarkable can happen. Suppose one particle is destroyed or annihilated. Its partner no longer has its original counterpart, yet the entanglement doesn't just vanish. Instead, the connection shifts. The surviving particle becomes entangled with whatever emerged from the annihilation of its partner. The link persists, just in a new form. Does that sound familiar? In a way, our lives are similar. Even after we fall silent, we continue to affect others. Our actions, our presence, and even our absence ripple through distance and time. Our lives flow into the lives of others, connecting us in ways we cannot always see. This story just reminds us that we are made of this same cosmic fabric. The microscopic particles that dance within us are connected in timeless communion. The forces that bind us are not merely physical. They are relational, like music born from vibrating strings. It arises from bowing of strings, which causes them to vibrate. But this music is something else than just atoms that compose the violin. It's in the particular relationship between them. It is a particular sequence. Likewise, neither your life nor mine can be reduced to the separate atoms that form our bodies. Our spirits and life paths are entangled like quantum particles that make our bodies. We are all connected in space-time through our thoughts and shared ideas. Death cannot localize us, neither within the bounds of space nor within the dimension of time. Next time you open your eyes, it will be you again, but with a different scenery and new opportunities, merged in the eternal dance of spirits and matter. We are the music of quantum particles meeting spirit, the eternal, entangled vibrations of the seen and the unseen. And somewhere, deep within that dance of matter and energy, the universe quietly unites us all, as if it were all one great love affair.